So let me introduce our last speaker of this morning session here. While they're setting up the infrastructure, Prasad Yalamanchi is CEO of Semantics. So he's also from the eastern part of the United States. In this role, he's also lead developer of TextDistill, which I think was mentioned quite some time already yesterday also. A tool to distill knowledge from language. TextDistill successfully harnesses large language models and semantic technologies to harvest highly accurate knowledge from language. Prasad's prime interests are language and knowledge, two sides of a coin, as he says. Welcome, Prasad, and stage is yours.
Well, thank you so very much, Yuta. Carlos is here. Carlos, thank you so much. It was a great talk.
Thank you.
Yeah, I understood quite a bit about the context in which ESG is kind of really played out. And it looks like it's a problem that is definitely getting a lot of attention and things like that. And technologists with almost no knowledge of ESG are getting swayed into looking at this problem. It's all around. I'll start off by introducing my topic, ESG data extraction from global news. Carlos mentioned Factiva, that's one of the sources of global news that we work with. And ESG is not new to this audience for sure. Environment and social governance is like taking on real prominence these days because, there is undeniable correlation between climate, calamities and economic damage. And that has, given rise to interest from the communities and governments and regulators and so on. And clearly businesses have, taken interest in this space, and along with the businesses, the investors have, are finding way into finding these opportunities. Again, governments and regulators are kind of insisting that the investors and investment firms declare, or kind of, disclose what their ESG performances are. And as was mentioned earlier, some of the, problems with companies themselves expected to declare what their ESG performance was, that it was leading to greenwashing, which is like claiming big things which probably could not be verified in any way. But nonetheless, they tend to get a good picture into the public, and as such, are misleading the public. And as such, more recently, in the last few years, there is this interest in focusing on alternate data, so to speak. Not the traditional data where it comes through regular channels and, through the government sources or, whatever, the regular submissions and, so on. Instead, these alternate data that consists of public sources like social media, which have nothing to do with the companies involved in that. In that sense, they tend to be a little more objective, much more objective than, is possible. And news happens to be one of those big sources. And hence our focus on news as one of the channels to, get this ESG related data. And we have integrated with Factiva Global News to do that. And that sets the stage for the topic, the technology side of extracting ESG related constructs and concepts and all the information, the factual knowledge out of, this flowing news that comes to this aggregation service. With that, I will get into my presentation. TextDistill is the technology that we are discussing. TextDistill, as the name suggests, it distills, as Uta mentioned, it distills knowledge in text and language. And when you say knowledge is more than just entities, and sentiment is clearly one of them. But it's much more the relationships among the concepts that you run into, and it tends to be orders of magnitude more complicated than just extracting entities, for example. So that's one of the challenges that we tend to focus here. Yeah. I'll go on to the next slide. So that brings the focus onto text. Why is text so challenging, and what may be interesting simultaneously with text? Text, unlike other sources of data, carries knowledge. For example, the other source of data might be like relational databases, spreadsheets, and what have you, right? And so they are, carrying information but not necessarily the full knowledge. I mean, there needs to be some kind of a shepherding by human element of some sort. Maybe it is another application on top of, ingesting data from a relational database, applying the metadata, and then, finally producing the knowledge that ends up, meaning something. So in its essence, the entire knowledge is encapsulated in a narrative text. The narration itself gives the authority of what the meaning is behind the concept that you run into and what the relationships that are kind of, are revealed in the rolling text. So that is the context of text itself. And so, and it's richer in that sense that it has all the information necessary to extract the necessary knowledge. And so, but up until now, without the technology support of, what has been happening in the last several years, it has been extremely difficult because it is very nebulous to kind of get at these things, especially these relationships and so on. And news, the other side of this news is that it is timely and it is actionable also. Like the example that I have here on the right-hand side is an article, snippet of an article from MIT Technology Review. At the time it came out, it's talking about the batteries for electronic vehicles. There is an innovation that is, put forward by this company, QuantumScape. And the innovation itself is that the liquids in these batteries was being replaced by a solid state. And the benefits of this innovation are that, the key elements of what you expect in an electronic vehicle is the range of the vehicle, and then safety. Liquids were prone to be a lot more, hazardous, and so solid state was, a lot more safer. And so both prominent parameters were being addressed in this innovation. And as such, it was a pretty serious news item. If you were to capture the news item and then, picked it up for all the knowledge it carried, it could have been actionable to folks that really knew what to do with it. Whereas without the technology of extracting knowledge from sources like this, you would have to wait for the normal channels to kick in, which is like your quarterly reports of companies involved and things like that. Who knows what type of distortions get into, and the fidelity of the sources and all of that stuff. And hence the importance of text is, I cannot underscore the value of it, especially if you know the source of where it's coming from. So the documents that, Carlos, you're mentioning, they really carry a lot of authority. And so you need to preserve all of that. And then, all the way without any, obfuscation along the way, lead it up to your final, intelligence that you are going to depend on. That's possible. Now, today with the technology like the LLMs and the knowledge graphs, knowledge graph technology has been around. Semantic technology has been in the academia for so long. It has matured and it is pretty rigorous. All of that is there. Now, together with these LLMs, it's very interesting. The combination is what really powers extracting highly accurate knowledge from these, textual, assets, as well as, as I intend to show you in a demo, querying these documents as such, And text distill, the actual software itself is a pipeline software. It takes in on one side the text documents. There could be sources from the web, internal corpuses, and I have some examples on the left-hand side. Given in the ESG space, for example, news, newsletters, social media, data, private, public, fund prospectuses, for example, you name it. Anything in written text, as long as there is a context, emails, a game, so on and so forth. As long as there is human readable content that humans would have made some sense out of it, we can make this system to produce some value out of it, automatically. And that, being that it is able to do that automatically, you get this unique opportunity to cover the, the scope, the volumes of this text that is getting published, day in, day out. And the interesting thing is that you feed in this text on one side, it produces completely structured knowledge graph or graph, in RDF triples. Those in this conference you all would know. RDF graphs are these knowledge graphs. The constructs are rooted in standards. And so clearly all that unstructured data is now available in highly structured, queryable, knowledge graph. And so the standard query language like Sparkle can directly get all the information that is extracted from these documents. And so what we have is, as part of text distill, this very interesting use case, which is knowledge graph search. For example, as you can see, it literally has a text input bar where you enter natural language query, and then that gets translated and posted back into the knowledge graph, and then you get the results. And of all the results, then we are looking at anatomy of one of those results. For example, item number 3, third result, it is producing this related to Nestle climate claims through its partnerships. It is talking about how Nestle has some kind of a relationship with coals, and then one of the divisions of Nestle is they are claiming carbon neutrality by 2025, and so that is an answer that was produced. The answer itself had come from multiple documents, so a single document did not have the answer for the question that you asked, and so the answer had to be put together from bits and pieces of text that are there in the corpus. And so it so happens it is 2 documents in this case, and so the 2 documents that have produced the answers are listed down below the answer itself, and with the title of the articles. And so, and the other thing is that you can double click on that item to verify if the answer indeed is coming from the claimed underlying documents. And then it kind of leads you into the exact snippets of it, and I'll have a chance to showcase that as well. So it is giving you that complex answers to verifiable answers to complex questions. In that sense, you are able to interrogate the text corpus, literally. So highly unstructured documents are now going to participate in your real answers that you're looking for, literally at your fingertips. That's the idea. And then there is another aspect of this tooling. We have this live alert system, which is not fully finalized and not delivered yet. It's in mid stage of development. But the idea is that the corpus is able to pick up on the signals that you have configured against the corpus, and the signals could be these complex questions that you are posing, and these are at a frequency that you configured. They are applied, these queries, against the corpus. And then if something kind of meets the criteria, that gets bubbled up as an alert and published. And then it so happens, as we saw, in cases where the answer had to be coming from multiple documents, and maybe only one document is already there in the corpus, but the second document hasn't had a chance to make it to the corpus yet. So it is like in an intermediate state, that alert itself. But whereas the new document, maybe it is in tomorrow's news, and so tomorrow's news article, when it hits the corpus, and the configured alert gets triggered, the query gets triggered, and then now it sees that, okay, this part of the piece of information is now sufficient to complete the entire alert, and it qualifies it to be published. And so in that sense, it kind of literally connects back to your history. For cases like fraud and things like that, this is literally invaluable. So for hidden documents and all that can participate in your queries that you come up with. So this is one of those things that I know our clients have been asking for. And with that, so I want to kind of take a few minutes to show you the actual demo. We are hosting this text distill at the site textdistill.ai. And before I jump on, and maybe on this slide, because we may not have a chance to get here, we are headquartered in North Carolina in US on the East Coast. And these are our contacts. Please feel free to reach out to me on LinkedIn, and then we can take it there. I will get to the demo. I'm just clicking on this. So we are on textdistill.ai, logging in through this public logins. So it puts us into this knowledge search interface. Before we get into the search, I would like to just show you what the corpus is. So the whole idea of this text distill pipeline is that you feed in the documents, and the documents gets processed through text distill. And so as part of the results of processing, what you are getting is the knowledge extracted, and the knowledge itself is like RDF triples, as I mentioned earlier. And so let's see what such a thing is. And for the sake of the demo, we loaded about 158 some odd documents. These are all global Dow Jones news articles. And I'll click on that corpus, and we can see what these documents look like. So these are all the documents, and this is an interface to kind of give you a handle on what the documents are. And I can click and show you what document is. So you can see this is a typical news article, running text. So it might make sense for a human, but for software, it kind of is a little difficult. Click on so just to give you a sense of these articles. So these are day in day out. These articles come in, and what does the knowledge, extracted knowledge, look like? I just picked up 4 documents here, and if I click on this interface here, it will show you the knowledge extracted, and that is stored, populated into an RDF knowledge graph at the back end. This is we are just looking at the underlying knowledge graph for these 4 documents, because we selected these 4 documents. These 4 documents, they have been broken down into 157 text blocks. And these are all the various concepts that have been extracted. And of course, this is a little bit messy, and it is, it's not meant to be readable. It is for you to kind of, hone in on specific areas of the graph if you're interested in. And there are many tools, support, interactions that will let you focus in on specific things. On the right-hand side, I don't intend to go through these things. This is for engineers, when they're trying to configure the underlying ontology and the taxonomy that is being applied to extract specific aspects of it. And if they are, suspicious that they are not picking up on certain concepts, then they can come in and visually see and inspect and see if the predicates are coming up properly or if the entities are characterized correctly. And, because there are plenty of thresholds, the machine learning models have a lot of thresholds that are getting applied. And so at times you may have to tweak these thresholds for something to be classified differently and, things like that. So in engineers, this is the great debugger interface. In fact, our engineers specific on project, they spend quite a bit of time here looking at single, article at a time, multiple articles, multiple documents, and seeing, are the concepts getting picked up right, are the predicates getting picked up right, and, on and on. So you can clear various things. And so there are many tooling here. So similarly, edge labels and, things like that, you can do that. So, but the focus what will be meaningful is, to show you the search interface here that, so this is on one side, the entire knowledge graph that is accessible. So I go back, right? This is the corpus. I go into the search, and search puts me in this, knowledge search interface. I go to open search. There are multiple things. I'll get to the signals in a little bit. And here I will select the ESG, corpus, and you are presented with this open text, text field where we can, like for example, who is working for which company, So this is, some question that you are asking the corpus, and hit enter, and boom, you get the answers here, So and you can look at these things. Now you can double click and go to the underlying, the actual, the answer that you selected, for example, here, and where is the substantiation for the answer that got picked up, and you can actually navigate to the source text blocks here and kind of read through this and see that, okay, this answer is indeed, what would have made sense for you for the question that you posed, which is like, is this person working for, in this case, we are asking a simple question: who is working for which company? So there must be a person, there must be a company or an organization. And so is the underlying source text, does that have it? And so you can verify that it is there. You can read through that if you are able to. And the other thing is, you can follow the text, or, if you're a little more curious and you're visually inclined, you can actually see the graph view as well. It just brings that portion of the graph that actually answered the question. And so with the concepts, again, you can bring up the node labels and edge labels, and I can move it around so that it is a lot more visible. Oops. Hope it is making sense. Yeah, and I can click on these things. These are nodes, that kind of lead you back into the actual underlying text itself. And I'll just go and do maybe a little more if I'm able to type. Let's say which company has invested in another company, let's say, right? Right, I'm asking a general free-form question here. And if there are any such things that are there, you will see these are the answers that are here. Like, for example, Barclays is making some 1.2 billion in this investment, and Barclays is, and you can, click through, any of these things and see, is that really the case? Double click and, go here. So here, Quanta Services doing some $2.7 billion, investment. So this is, as you can see, it literally takes you to the underlying text. And this could have been, a corpus of million documents, and your question could have been much more complicated than just single proposition or multi-proposition. I'll show you. Of course, I can't type correctly a long propositional question. And the same thing, by the way, you can see the graph view as well. But what I intend to show you is the other concept of what we call signals. Signals are same thing as these free-form queries, but once that you have played with these queries and you have satisfied yourself that this is the exact query that you want, and so you kind of have a chance to play with it, like try different queries, in complicated queries at that, because a typical analysis that really produces some value are generally complicated and multi-propositional. It is multi-hop in that sense. So I will bring up, and then here what we have an opportunity is you create that query and give it a name, and we call that a signal, and so that you don't have to retype that entire query each time. You just call it by a signal name, and then you just boom. It kind of applies that big long query, and I would like to do that here. So for ESG, we have under signals. There is one signal that we set up for our demo, and this happened to be popular with the analysts, investment analysts. And this one is talking about organization A is investing in or has a business arrangement with the organization B or C, and so on. And these organizations B, C are reporting on some kind of a green variable or a climate variable, and these climate variables have certain measure, and then they are reporting all this by a certain period. So as you can see, it's a 4 or 5 propositional query. So typically these are like pretty complicated queries underneath. And so with a signal, you can, because you don't want to give in values for all these variables, you anchor it with, 1 or 2 of the entities. And in this case, we anchored it with an organization, which happens to be the organization A. So, and the system automatically detects all the organizations in the corpus and it presents it to you for selection. And I think I have Barclays. I have seen that. For example, I gave Barclays. Barclays is this big bank, and and that is now inserted into that signal as organization A. And now we are looking for rest of the query. Is there anything in this corpus that fits this signal that you're looking for? And it turns out, we are only showing you, top 10, and there are quite a few of these things, that are common, maybe 20 of these. And you can go into any one of these and, you can see the top one, for example, Barclays is investing 2.2 billion in business arrangement with Chevron. And Chevron is aiming to eliminate, routine gas flaring, a significant source of emissions by 2030. And, as you can see, by 50% the reduction from 2016 and so on. And so this is, you can see that it fits the signal that you're looking for. And what it is telling you is that it is coming from these two documents. There is one document with this title, Dirty Deals Between UK Banks and, whatever. The other one is Democrats press, with GOP attacks and Biden policies and so on. So now we want to verify, is it really coming from these two documents and, where exactly this, source of truth is within those two documents. I can double click. And it takes you here, with the underlying the same answer with the, the sources here this time. So you can click on these things and, see, follow, what it is. So instead of having to read through the entire document, you are now, at least supported by, having to read just this, few sentences or maybe a sentence. And you can verify that that's what is the case, so click around and just, different portions of the answer are now verified with these things. And again, the same thing, you can go to the graph view and then get the same thing. So again, this graph was part of the underlying knowledge graph, and it's only picking up the subgraph that fit the answer that you're looking for. So you could not do this subsection or subsetting of what needs to be promoted as an answer without having the underlying knowledge graph. So, and hence the text is still processing, applying all the technology and all that. Really comes in handy to kind of, help you get here. So I can bring up the node labels and edge labels, and you can follow through these things, and so I'm not going into the details, even you're all now you're able to follow, right? And you can follow the predicates, and something says, like we said, $2.2 billion is invested. And so the investor is, investee is the Chevron, and Barclays is the investor. So once you get to know, what this, how to read these predicates on the edges, then it's immediately apparent for you. Well, with that, I would like to stop here because, primary idea was to kind of, really give you a sense that there is a working system that really gets in between lines of, running text and brings out facts and concepts and all of that are driven by an ontology at the back end. In that sense, this system can be applied to different domains. Again, you just need the ontology of the domain to drive the system. That's the promise. Yeah.
So thank you, Prasad.
Thank you.
Thank you very much for the nice work. So I understand the part about entity linking. Can you elaborate a bit more about relation extraction? So which kind of, I guess you have a dictionary of relations and you focus on them?
Right. Yeah. At least, because we have an ontology at the back end that gives us a guiding, rationale for what constitutes an allowed relationship between entities. And it doesn't give you an exact, latch to kind of pull up because the words may not match. Our predicates, is investor here, but there is no investor in the text if you were to look at it. So again, we have to kind of, match them by our machine learning and all of that in the middle.
So it's basically you have a machine learning that learn a set number of relationship
on the fly,
and then you try to extract this relationship.
Exactly, and the ontology kind of gives you the guiding post so that you are within the scope of this particular predicate, which is an investor in this case. And here it may be saying that somebody has provided money. In this context, provided kind of suits to be matched up with investor. In this context, only in this sentence. Elsewhere, provider may be something else.
Does it mean that you need then some gold standard or some example for each relation that you're extracting?
Yeah, there is definitely some training that we do, and there is a lot of synthetic data that we generate for training based on an ontology, just for training purposes.
Okay. I understand.
And we use verb nets, and there are a lot of resources are there, so that kind of allows for, because now we are in the realm of pure language. Yeah, and there is plenty of resources that we can corral to, because now the context is set together, so we really can aim for whatever the accuracies that you're looking for.
Great talk.
Thank you.
And I see you use a lot of like standards, like the ontologies and the graphs, but you also derive very valuable insights. And is there also some way in which you could expose those insights using open standards as well?
Yeah, absolutely. Because the knowledge graph is in completely standardized, W3C RDF, right? And so we actually publish in LinkedIn, JSON LD, So, it depends on the client, if they want to really publish the outcome.
Because could you expand a bit on that? Like, is that like maybe a feed that you can have a subscription to? Because this is very valuable information.
Yeah, but
because you generate those insights.
Absolutely. But we are a technology group, so we do ESG and in one area, and we have done crime in another place. So we are not wedded to these application areas. The clients themselves own the data pretty much, and so it's up to them. But the technology is there. We publish, JSON LD, which is kind of, you can literally convert this into a federatable knowledge graph that you can really apply Sparkle and some another source, and then that can link to this source and club these two things to produce a nice BI chart for you. But the data has to be, approved by the client.
Yeah, I understand. Thanks.
So, any more questions? Well, thank you very much. Actually, I'm into knowledge, very much into knowledge. So I really appreciate you understanding that there is knowledge and that is more than just data.
Absolutely.
So thank you very much for that talk. And with this, we are closing the session. I know there is one coming up in Iphigenia in 10 minutes. So there's another hour to go before there's lunch. So thank you very much for joining us here.
Thank you.
Thank you.
Hey, hi, how are you doing? You know me or not yet? But